So I had the integral of parentheses natural log of x to the natural log of x minus 6 parentheses plus 5 parentheses x cubed dx, all of the integral of 1 to e squared. This is a Desmos graph of my integral. So in part 1, the first question asks my initial thoughts on the function and what I thought it looked like. So obviously I thought it looked like a natural log function mixed with a polynomial, and that is what I thought that I would need to be thinking. That is what was going through my brain, that this is gonna be a natural log, a mixture of natural log and polynomial function. Second question asked me what methods I ruled out and what methods I deemed necessary to find the integral. So looking at it, I can immediately cross out anything to do with trig. So I cross out trig sub, inverse trig sub, product of powers of trig functions, because my problem has nothing to do with trig. Second, I was able to cross out partial fractions because my problem does not have anything to do with fractions either. Next, I identified that I would be using u sub in the form of reverse power rule and biparts combined in this one equation or integral. So the u sub I thought I would need for the natural log of x minus 6. I was wrong about that, as I would later find out, but I did still use it for 5x cubed because that would require reverse chain rule to solve. And then I identified that I would definitely need biparts to deal with the natural log, because natural log doesn't really have an antiderivative for it that I knew. And because of that, I knew I would have to use natural log, and I would use the Lipit rule. So natural log comes first, then inverse trig, then polynomials, and then so on, so forth. But it was really the polynomials and natural log that I needed only for this equation. Question 3 basically solve the equation or the integral. Step 1, first thing I do is rewrite the integral, and then I distribute the x cubed in. So now I have my integral of x cubed times the natural log of x to the natural log of x minus 6 plus 5x cubed dx. So now I separate these two integrals in order to make it easier to solve my question. And I find the integral of 5x cubed dx, which is 5x to the 4 over 4. And then I now have the integral of x cubed natural log of x to the natural log of x minus 6. Step 2, I move just the integral of x cubed times the natural log of x to the natural log of x minus 6 in order to focus on just that, because I already found the integral of 5x cubed. So over here I was confused because I didn't know if x minus 6 was if the natural log was of natural log of x minus 6, or if it was natural log of just x and then minus 6 on the outside. So I plugged it into Desmos to make sure, along with the answer that was given to me on the MIT integration bee, and I learned that it was the natural log of x separately minus 6. And this made it much easier to solve because I also remembered that when you have the natural log of something to the power of something else, you can take whatever that power is and bring it to the front of the natural log. And that is what I did here. I took the natural log of x minus 6 and I brought it to the front of the natural log, which gave me x cubed times the natural log of x minus 6 times natural log of x. First thing I do here is distribute x cubed in. So now I have parentheses x cubed times the natural log of x minus 6x cubed, parentheses, times natural log of x. And then I distribute the natural log of x in as well. This leaves me with x cubed times the natural log of x squared minus 6x cubed times the natural log of x dx. And then I separate these into two separate integrals in order to more easily solve it. So now I have the integral of x cubed times the natural log of x squared dx minus the integral of 6x cubed times the natural log of x dx. So step 3, I only rewrite the integral of 6x cubed times the natural log of x dx because I believe this would be easier to find the integral of. And I knew I would be using biparts here, so I quickly rewrote the biparts rule on the top right, and I identified my f of x and g prime of x as f of x equaling natural log of x and g prime of x equaling 6x cubed. Now that I had identified them, I rewrote it as I rewrote it into the biparts rule. So I got the integral of 6x cubed times the natural log of x dx is equal to 3 over 2 x to the 4th times x to the 4th, which is just g of x, times the natural log of x minus the integral of 3 over 2 x to the 4th times 1 over x, which is the derivative of natural log. I can now simplify this as 3 over 2 x to the 4th times the natural log of x minus the integral of 3 over 2 x cubed times x cubed dx. And then over here, I just use reverse chain rule or reverse power rule. And I now know it equals 3 over 2x x to the 4th times natural log of x minus 3 over 2x to the 4th. Finally, I check it by finding the derivative of my answer just to make sure that I did it properly. Step 4, just as I had predicted, the next part was more difficult to do. So now I have the natural log of x cubed times the natural log of x squared. Once again, I rewrite my biparts formula on the top right, and I identify g prime of x to be x cubed and f of x to be the natural log of x squared. So now I find so now I plug it all in to the biparts formula. So I have the natural log of x cubed times natural log of x squared dx is equal to x to the 4th over 4, which is g of x times, or the antiderivative of x cubed, times natural log of x squared minus the integral of x to the 4th over 4 times 1 over x times 2 times natural log of x. This is going to be the derivative of natural log of x squared. This leaves me with, after simplifying, this leaves me with x to the 4th over 4 times the natural log of x squared minus the integral of x cubed over 2 times the natural log of x dx. Once again, I realize I will need to use biparts again, so I identify g prime of x to be x cubed over 2 and f of x to be natural log of x dx. And now I find the derivative, the antiderivative of x cubed over 2 times natural log of x, which I find equal to x to the 4th over 8, which is going to be the g of x for x cubed over 2, or the antiderivative of it, times the natural log of x, minus the integral of x to the 4th over 8 times 1 over x, which is the derivative of natural log of x. This is going to be equal to x to the 4th over 8 times the natural log of x minus the integral of x cubed over 8 dx. And then I solve the integral and I find the answer to be x to the 4th over 8 times the natural log of x minus x to the 4th over 32. Now, because all of this was part of the original the original integral of x cubed times natural log of x to the power of 2 dx, and this portion that I just solved was part of the negative integral of x to the 4th over 4 times 1 over x times 2 natural log of x dx. I have to I have to distribute the -1 into my equation. So I am left with x to the 4th over 4 times natural log of x squared minus x to the 4th over 8 times the natural log of x plus x to the 4 over 32. And then next I check my answer to make sure that I solved this integral properly, and it turns out I did. So I move to the next step. In this next step, all I really do is rewrite each individual integral separately, and then I write down the answer for each integral all together. At the end here, I just simplified my antiderivative by finding the least common denominator, which wasn't really needed, but I felt like doing it, so I did it anyway. So continuing step 5, this is the rest of my work in finding the final check for my answer. And then, of course, I plug this into Desmos as well, just to make sure that my answer is the same as what Desmos says. Sure enough, it is correct. This is the graph of the antiderivative.